Welcome to Foundations of the Future, Part 2. 3 topics here today. The first one is vertical farm versus greenhouse. The second point is a review of a Milken Institute study on the cost of diet-related disease, specifically diet-related disease. And then third, we're going to have a quick look at quantum computing in the future tech section of the podcast. But first, let's have a look at the comparison between vertical farms and greenhouses. To give a quick intro, greenhouses are plant production systems that are indoors, but they still use sunlight. The roofs are typically made of glass or some kind of plastic material. And vertical farms are farms with 2 major differences. Number 1, vertical farms do not use sunlight, or they very rarely use sunlight. And second, the vertical farm uses the third dimension that greenhouses and outdoor farms don't use, which is vertical or up. Commercial greenhouses have been around since about 1920. They've been around for a very, very long time. You've been able to build one or acquire one for 100 years. Vertical farms, certainly not the case. I would say you have had market viable solutions for maybe 10 years. Greenhouses have largely reached steady state in terms of their ability to drop the cost of the facilities themselves, and the same with outdoor farming. They're largely in a steady state. Terrible idea to drink fizzy in the middle of the podcast. When would we use a vertical farm and when would we use a greenhouse? And that's what I've tried to summarize here in this little blurb. You're going to see a stratification of vertical farms, greenhouses, and traditional farms. You're going to have traditional farms growing all of the products that are weighed per ton. You know, corn, wheat, soybean, these kinds of products, coffee bean. These are the products that are going to be grown outdoors for a very long time. And then you have the greenhouses that will typically be growing the vine crops or the larger vegetables like cucumbers and peppers. And then you'll have the vertical farms growing all of the higher value products. The higher value products, of course, include berries, lettuces, leafy greens, microgreens, herbs, cannabis maybe. But it's actually the union between the 2 technologies that is most interesting. The best example of this union is when you put vertical farms as the nursery for greenhouses. So imagine a football field, American football if you like. Even though it's not really football. Take a football field. Let's say up to the 20-yard line or up to the 40-yard line. You have plants that are very small. They're not highly productive. You're wasting a lot of area on these baby plants. And then from the 40-yard line and beyond, I think I'm doing this correctly, you have mature plants. So what if, again, we take that whole football field. What if we take up to the 40-yard line and we pack it super densely into a vertical farm such that it'll fit in a quarter of the end zone. And then we take the remainder of that area up to the 40-yard line and we expand out the area under glass that is growing the mature plants. As you can imagine, in this case, we've then gained about 40% more yield out of the football field. The numbers are actually a little bit better than that, but hopefully that's illustrative. Let's go through portion number 2 here, the tragic costs of diet-related disease. Oh boy, everybody, we're about to get a D-. This is a study done by the Milken Institute. It's called America's Obesity Crisis, the Health and Economic Costs of Excess Weight. Obviously a touchy subject, but I think it's a very important subject that we be honest about in order to be able to solve the problem. I think we should apply that across all of these problems. Many problems in the United States today have become very touchy, and I think it's of course, important for all of us to be very respectful at all times when discussing these difficult issues. But at the same time, we have to be able to say what's true, even if it is a painful thing to hear. So already within the first sentence, in 1960, the rate of obesity amongst adults was about 3.6%. By 2016, that's at 40%, a D- in health. Now, that tells us a couple of different things. First of all, we can exist in a world where obesity sits at about 4% of the world's population or national population. So we can't blame our state of health on our genetics or our biology. They couldn't possibly have changed that quickly. Our environment obviously has changed somewhat with the foods that we consume and the way that we live, the sedentary life that we now live. But let's look at this first sentence. Incredible. 1960 it was 4%, now it's 40%. What on earth has gone wrong? What food do we eat? We didn't have to look too far, did we? 70% of adults in the United States today are overweight or obese. 70%. The economic impact of excess weight, the Milken Institute summarizes, is about $1.7 trillion per year. That's almost 10% of US GDP. Not all disease, diet-related disease. 47%, almost half of the money that we spend on treating chronic illness is because of excess weight. Incredible. Here in Table 1, we get a quick look at the total costs of excess weight. In summary, we have about $480 billion in direct healthcare costs to excess weight. And then we have about 1.2 trillion in, let's just say, lost productivity. That's how we add up to a $1.7 trillion number. What is the best way to decrease weight? Increase your consumption of vegetables, decrease your consumption of sugar, go for a walk, get hours of sleep, don't stress too much, do some yoga or something. Let's just go through the references one by one. Ladies and gents, this was the table that I wanted to show you. Table 6 here. This talks about the relative risks of having excess weight as they relate to different ailments. So here we have, up the top here, just to give you a reference, Alzheimer's and vascular dementia. If your likelihood of developing this ailment is a 1, if you don't carry any excess weight, it's 2.04 for Alzheimer's and vascular dementia. Our population is eating very poor food. 70% of the United States population is overweight and obese. A D- in health. We eat poorly and we don't exercise. We gain weight, we become sick, and then we medicate ourselves. A D- in health. If all you're doing is treating the symptoms, you're not going to have much luck in solving these problems. And in fact, I think the only regimen that showed ever to reverse heart disease was a strictly plant-based diet. Keep that in mind, that so many of these ailments can either be significantly improved or fixed by changing the diet of these patients.
I had candy.
Future Tech, Section 3. Now we know that nuclear fission often lies in this category. We know that nanotechnology often lies in this category, but also quantum computing. Now, according to Google, they've made their quantum computer 271 million times faster. Do we really need faster computers? Current clock cycle on an NVIDIA graphics card is something like 2.5 billion clock cycles it can complete per second. We don't really need faster computers, but we do need computers that can solve different kinds of problems. The best example of one of these problems is called the traveling salesman problem. Imagine you're a salesman and you have to travel to 61 cities around the United States to make your sales pitches or deliver product. If you were trying to compute with a classical computer which path through those 61 cities was the shortest, there are more possible paths to those 61 cities than there are atoms in the universe. So a classical computer isn't going to solve that problem very well, but a quantum computer will. I probably wouldn't hold my breath for a quantum computer to be on the shelves within the next 5, maybe 10 years. There are still lots of problems to solve, mainly the temperature issue. These quantum computing chips have to be kept unbelievably cold, and the infrastructure required to keep something at minus 270 degrees Celsius is not cheap. So what did Mum always tell you? Eat your greens, watch your weight, and make sure you filter out quantum noise. Have a good day. See you in episode 3. It's bedtime.